Bismillahirrahmanirrahim. Hello, my dear students. How are you? I hope you are fine. Today, inshallah, we will talk about Mathematics of Finance, Part 2, which is dealing with the compound interest. And we will start with the first chapter under the title of The Future and Present Value at Compound Interest. And we will start with the first problem. Problem number 1. How many quarterly conversion periods are there from June 2002 to December 2008? To calculate the number of periods, we need to calculate the total time. Then calculate the number of periods. Solution. We will start with the date of December 2008 minus the date of June 2002, and we will start with days. 20 minus 20, which is equal 0, 12 minus 6, which is equal 6 months. At the last, 2010 minus 2002 equal 6 years. So the total time is 6 years plus 6 months, and n will be equal 6 months, 6 years times 4, because of its every period equal 3 months. It's a quarterly conversion periods. So in 1 year there are 4 periods. Every period equal 3 months. And for 6 years there are 24 periods. And in 6 months there are 2 periods, which is every period equal 3 months. So the number of periods will be equal 24 plus 2 equal 26. Problem number 2. How many semi-annual conversion periods are there from June 15, 2010 to December 15, 2021? In this example, he deals with a semi-annual conversion periods. So in 1 year there are 2 periods, which is every period equal 6 months. And to calculate the number of periods at this distance of time, we need to follow the next step. We will start with December 15, 2021 minus June 15, 2010. So the total time here equal 11 years plus 6 months. So n will be equal 11 times 2 plus 6 over 6 equal 23 periods. Problem number 3. How many monthly conversion periods are there from October 5, 2000 to March 5, 2004? The answer. We will start with the date of March 5, 2004 minus the date of October 5, 2000. So the total time equal 3 years with plus 5 months. So to get n, we need to multiply 3 years by 12 and dividing 5 months over 1. So the number of periods will be equal 41. Problem number 4. A bank provides consumer loans at an annual rate of 12% compounded quarterly. Find 1. Nominal interest rate. 2. Number of compounding per year. 3. Periodic interest rate. So, the nominal interest rate is the rate per year. In our example, the rate per year will be equal 12. Number of compounding per year. In our example, we're dealing with a quarterly periods. So there are 4 periods in every year, which is every period equal 3 months. At the end, periodic interest rate, it's equal the division of nominal interest rate over number of compounding per year. Note that we sample the nominal interest rate with letter J, and for the number of compounding per year with the letter M, and for the periodic interest rate with the letter of I. Solution: to get I, we will dividing J, nominal interest rate, over M, number of compounding per year. Note that per year, not for the total time. In our example, nominal interest rate equal 12, number of compounding per year equal 4, so M equal 4, so I will be equal 12% over 4, which is equal 3%. Problem number 5. Calculate the periodic interest rate corresponding to 7.5% compounded annually, 7.75% compounded semi-annually, 8% compounded quarterly, 5% compounded monthly. So we need to calculate the periodic interest rate. We know that I equal J over M, and for A, nominal rate equal 7.5%, and M will be equal compounded annually, so M will be equal 1. And for B, nominal interest rate equal 7.75%, and M will be equal semi-annually, so M equal 2. And for C, the nominal rate equal 8%, and M will be equal 4. At the end, the nominal interest rate for D will be equal 5%, and M will be equal 12. So we will substituting for A with J 7.5% and M equal 1, so I will be equal 7.5%. We note that J will be equal to I. And for B, I will be equal 7.75% over 2, which is equal 3.875 per thousand. And for C, I equal 8% over 4 equal 2%, and for D, I equal 10.5 over 12, which is equal 8 per thousand percent actually. Problem number 6. For a nominal interest rate of 10%, what is the compounding frequency if the periodic interest rate is 5%, 2.5%? In this example, he gave you the nominal interest rate plus the periodic interest rate. So the unknown here is M. From the formula, I equal J over M. To calculate M will be equal J over I. In this example, J will be equal 10%. And for A, I will be equal 5. And for B, I will be equal 2.5%. Let's show the answer. For A, we will substituting J equal 10% and I equal 5. So M will be equal 10 over 5% equal to periods. This means it is semi-annual compounding. And for B, where J equal 10% and I equal 2.5%, so M will be equal 10% over 25 per thousand, which is equal 4 periods. This means it's quarterly compounding. Problem number 7. Determine the nominal rate of interest if the periodic rate is 14% per semi-annually. The periodic rate is 5 per thousand per month. The periodic rate is 1.5 per quarter. Number 2, again, the periodic rate is 5 per thousand per month. Solution. Where is I equal J over M? So J will be equal I times M. For A, by substituting I equal 14% and M equal 2 periods, so J will be equal 14% times 2, which is equal 28%. And for B, where is I equal 5 per thousand, M equal 12, so J will be equal 6%. And for C, by substituting I equal 15 per thousand, M equal 4, so J will be equal 6%. Problem number 8. Calculate the missing values. In this example, there are 3 columns. The first column, nominal interest rate, J. The second, compound frequency, M. The third, periodic interest rate, I. So, if we need to calculate any item of 3 items, we need to know the other 2 items. For number 1 and 2, we need to calculate I. We know that I equal J over M. So, in number 1, J equal 10% and M will be equal 4 because of it's quarterly. So, I will be equal 10 over 4. And for number 2, I will be equal 12 over 2 because of it semi-annually. And for number 3 and 4, we need to calculate M. M equal J over I. So for number 3, M will be equal 18% over 9%. And for number 4, M will be equal 6% over 1.5%. And for numbers 5 and 6, J equal M times I. We know that M in number 5 will be equal 12 because of it's a monthly. So J in number 5 will be equal 12 times 4 per 10,000. And for number 6, where is M quarterly? It means M equal 4, so J will be equal 4 times 3%. The answer for A, or for number 1, 25 per thousand. For number 2 will be equal 6%. For number 3, semi-annually, that means that M equal 2. And for number 4, M equal 4 quarterly. And J in number 5 will be equal 54 per 10,000. And for number 6, J will be equal 12%. Another example. Calculate the missing value. As the previous example, we calculate I from the formula of J over M for number 1 and 2. And for number 3 and 4, we calculate M from the formula of J over I. And for number 5 and 6, we calculate J from the formula of M times I. Note that in the second column, compounding frequency, N1 quarterly means 4, M equal 4. Semi-annually means M equal 2. Monthly, it's mean M equal 12. And quarterly, M equal 4. The answer, 6% over 4 equal 1.5%. 12% over 2 equal 6%. And 20% equal 5% equal 4. So M will be equal 4. 9% over 9%, that's mean M equal 12. And for number 5, J will be equal 12 times 1%, so J will be equal 12%. And for number 6, M equal 4, I equal 6%, so J will be equal 6 times 4, which is equal 24%. Next example. Calculate the missing values. As the same, note that in number 1, M equals 3, it means that the period here equal 4 months. Each period equal 4 months, not 3 months. So I equal J over M, 6% over 3, and for 2, 10 over 2. For number 3, 16 over 4%, 16% over 4, and for number 4, 9% over 3%, And for number 5, J equal M times I, so 12 times 2 at the last, J equal 4 times 2. This is the answer. Problem number 9. What will be the future value of $20,000 invested for 7 years at 8% converted quarterly? So in this example, we need to calculate the future value. It means we need to calculate the amount for the principal or the present value of $20,000. We will substituting for J equal 8% and M equal 4, so I, periodic interest rate, will be equal J over M equal 2%, and N will be equal 7 times 4 equal 28 periods. The time diagram shows that there are 7 years, and for every year there are 4 periods. So the interest will be added 4 times in every year. And to calculate the future value, we will use the formula of FV equal PV times 1 plus I to power N. FV, the amount or the future value. PV, present value or the principal. And I, the periodic interest rate. And N, number of periodic periods all over the time. And for BV equal $20,000 and I equal 2% and N equal 28, so the amount or the future value will be equal 34,820. Note that FV must be greater than PV. Problem number 10. A savings and a loan association pays 6% compounded quarterly on a savings account. A man puts $15,000 into an account on February 3, 2010. Finds the amount in his account and the compound interest on August 3, 2030. In this example, we will substituting for J equal 6%, M will be equal 4, and I will be equal 6% over 4, which is equal 1.5%. And to get N, we must calculate the total time. So, August 3, 2013 minus February 3, 2010. So the total time, 3 years, 6 months. So N will be equal 3 times 4 plus 6 over 3, which is equal 14 periods. This is a time diagram. The future value, FV equal PV times 1 plus I to power N. For PV equal $15,000 and for I equal 1.5% and N equal 14, so the future value or the amount equal 18,476. And for the interest, And for the interest, we can calculate it by two types or by two ways. The first way, we know that I equal the amount minus the principal. I equal the future value minus the present value. So I will be equal 18,476 minus 15,000. So I will be equal 3,476. The other solution, from the formula I equal FV minus BV, we will substituting for FV by BV times 1 plus I to power n. By taking BV as a common factor, so the compound interest equal BV times 1 plus I to power n minus 1. So I will be equal 3,476. The same result as the first way. We will stop here. See you next time and thank you.